Welcome back to Further Solutions Academy. Further Solutions Academy. Encourage us more to share our video anywhere you see it and subscribe. Just press the subscribe red button by your so that for direct updates. At this point, we have a lot of videos for you can play with. A lot of videos, close to 400 videos. Above 400 videos. It means you can come here and learn any topic of your choice: mathematics, physics, and chemistry. Okay, just in case you want to reach us, want to book for our online class, or you want to make a comment, you can comment below, or now with this line you can reach us, you can call us, you can WhatsApp us. And also Telegram is allowed. That'll be three. Okay, on this video I'll be walking you on adjoint of matrix. Adjoint of matrix. Outline of this video: the first one is transpose of matrix, cofactor, and adjoint. By the end of this video, you will understand what is here. You will understand it very well. I promise you. Just calm down. You'll be fine with it. Now, let's start from transpose to cofactor to adjoint. Transpose to cofactor and adjoint. Now, if I am talking about transpose, what I need to understand now is that you are talking about transpose of matrix. Now, it's not hard. Transpose of matrix is denoted by MT. It means matrix raised to power T. That is the transpose of matrix. Mostly that is how people indicate it or write it. Now, but when you hear word transpose, it means the row will change to what? Column. The row will change to column. That is all about transpose. Now, for instance, when I have matrix B equals to AB, now B transpose will be equals to BA, AB. That is all about it. This is the matrix. This is the transpose of the given matrix. Now, for instance, if I have a matrix A equals to ABCD, transpose of this particular matrix will be equals to ABCD. That is what I mean by transpose. Now, if it is 3 by 3, which is 3 by 3 square matrix of 3 by 3. Now, what I need to know is that when I have my transpose of my M is like this: A, B, C, D, E, F, G, H, I. Now, the transpose of this, my M transpose, will be equals to A, B, C, D, E, H, C, F, I. That is my transpose. It means the row will change to what? To column. The row will change to what? Column. That is transpose of a given matrix. That is how it's being done. Now, for instance, if somebody give me a question to attempt, like for instance, I saw this question from one who said to me, let me try to concentrate on the point. Let's see how it will go. Now, look at this question. I have given that A equals to -2, 4, 1, and -6. Obtain A plus A transpose bracket of transpose. Now, what we need to do is that we all know that my A transpose will be equals to what? -2, 1, and 4, -6. That is very good. Now, if I have my A plus A transpose now, it means I will be talking about what? -2, 4, 1, -3, 6, plus -2, 4, 1, minus 6. Now, it means I will be talking about this plus this. It will be minus 4, and this plus this, it will be plus 5. This plus this, it will be 5. This plus this, it will be minus 12. Now, that is the addition of the of that. Now, since it's that addition, A plus A transpose bracket of A, bracket of the transpose, it means my answer, I will transpose it. I will transpose what I have, like what I gotten already, which I will be having. It will now be what? Minus 4, 5, and 5 minus 12. That is all about that. Now, that is what I mean by transpose. It will, change to what? Now, at this point, let me quickly explain adjoint of, given matrix. Before we talk about adjoint, before we talk about cofactor, let me quickly explain adjoint of 2 by 2 matrix, which is 2 by 2 square matrix. Now, for instance, if I have A equals to A, B, C, D. Now, adjoint of A will be equals to D, E. I will change the position of the principal diagonal, which I will rotate it, I will take it, this one will go up and this one will come down. Now, I will now attach minus to the other side. It means this is the adjoint of a matrix. Now, for instance, if I have in the form of number, I have A equals to, let me play with a number, 2, 3, 4, 5, and adjoint of a given matrix, of this given matrix, adjoint of A will be equals to 5, 2, minus 4, minus 3. But it's not like that in the case of what? The other one, which is 3 by 3 square matrix or more. It's not like that. If the story changed to 3 by 3 square matrix, you have to find the cofactor. We call it row reduction. After that, you will transpose the cofactor, which it will lead you to the what? To the adjoint of what you are looking for. Now, for instance, if somebody asks me to work on, for instance, you ask to now to find a transpose adjoint of 3 by 3 or more matrix or more matrix. Now, what you just need to do, anytime you are asked to find 3 by 3 or more matrix, you can only do that for 2 by 2. But if it is 3 by 3 or more, but it must be square matrix anyway. Now, what you just need to do, it is very simple. What you just need to do, you find the cofactor. Now, cofactor of matrix with transpose equals to what? Adjoint of M. That is what I mean. It means you find the cofactor of that particular matrix and what? And transpose it. And transpose it. When you transpose it, that will lead you to what? The adjoint of 3 by 3 or more matrix. Now, I will be giving an example to illustrate my point so that you'll be able to see it clearly, because time is not on my side anymore. Okay, look at this. Look at this. Now, look at this question. I have if A equals to 1, 0, 1, 2, 1, 2, 3, 4, 2, 1. Find 1 cofactor of A, 2 adjoint of A. Let's try to play around with this question, solution to this problem. Now, at the point of finding the row reduction, that is where the sensitive part is. How do I find the row reduction of a given matrix? Now, it will be equals to, the first thing is, I will come like this. Now, don't forget the logic, plus, minus, plus, minus, plus, minus, and plus, and plus. I think I've explained that earlier. Very, very important. And this is the time to utilize that statement. I mean, this on this. Now, to find my row reduction, what I will need to do, the first one is just like this. Now, it will remain this. It means determinant of 1, 3, 2, 1. Now, plus will be here, which is plus. And the next one will be what? This. And this, left with what? Now, it will be, please take note of this, very sensitive, because it really took me a lot of time before I understand it then. The next one will be this and this, left with what? This and this. It means determinant of 2, 4, 3, 1. Please, I'm not using normal bracket. I'm using the determinant bracket. Take note of that, because I'm to result at what? At scalar. Minus is here. It means minus will be attached to this place. The next one, it will be now the next one we also move on to the okay, I'm coming. Now the next one will be this and this. Now left with this, it means I will be talking about determinant of 2, 1 and 4, 2 and minus, plus will be here. Please take note of that sign. It's very, very important. Now the next one, what makes it different from the determinant is that it will continue by going this way and also going this way. Now left with, that one will be minus, which is this minus, and I'll be talking about 0, 1 and 2, 1. I will move on to the next one, which is going to be what? The next one will be determinant of, which I will be having the same thing like this and like this, which I will be having 1, 4, 1, 1, which it will be plus. And the last one will be determinant of, which is going to be cos. Now it will be 1 is 0, 4, 2. That will be minus. Please take note of the way I'm doing it. The last part of it, which is the last row, which is the third row. The third row will give us something like this. Now, take note of the third row. The third row will be like this and like this. Left with the upper one, which it will be, what is here? Plus, and it will be 0, 1, 1 and 3. And here will be minus, which is going to be what? 1, 2, and 1 and 3. And the last one will be this and this, which will be 1, 0, 2 and 1, which is going to be plus. Now that is called, what I'm doing here is what? Is cofactor. It's row reduction. Now it means it will be equals to, I have to utilize this thing very well because of my board. Now it means it will be equals to it will now be equals to this times this times this, 1 and 6. 1 minus 6, it will be, it means this times this is 1, this times this is 6, which I will be having minus 5. This times this is 2, and this is 12, which will be 6 and 12. Now, I have to show you how that comes up. Now, it means I'm talking about 5, bracket of plus, and this one will be 12, 10. it means I'll be having minus bracket of minus 10. Now, here will be 4 and 4, which is going to be 0, plus bracket of. Now, the signs are coming down. These are the signs I'm trying to work on so that you can be able to see it clearly. And here will be 0, here will be minus 2. It means minus of minus 2. And here will be equals to minus 1 minus 4. That will be what? Plus of 3. And minus 2 is 0, which is going to be what? Minus of 2. Now, and the last one will be 0, and that will be plus of 1, of minus 1, which is going to be, this one will be minus 3, plus 3, and which is going to be minus of 3, minus of 1, this will be 0, and 1 and 0, which is going to be plus of 1. Now, which it will give me a particular matrix. Can you see the implication of those signs standing by from here? Please take note of that. It means my cofactor, my A cofactor will be equals to 5, 10, 0, 2, 3, minus 2, minus 1, minus 1, and 1. That is my cofactor. That is my cofactor. Now, there is a matrix on its own. Now, adjoint. Now, if I transpose cofactor of, if I transpose it like this, become a what? Adjoint of A. Now, if I transpose this particular matrix now, what I just getting from my cofactor, that generates my what? Generates my what? My adjoint. It means my adjoint of A will be equals to 5, 2, minus 1, 10, 3, minus 1, 0, minus 2, and 1. That is my cofactor. That is all about that. Can you see? It's very, very simple. That is what I'm trying to work towards. That is very well. Note that when you transpose your cofactor, we generate a what? Adjoint. Okay. In my next video, I'll be working on inversion method. Inversion method. How to use this to solve some mathematical problem. Like simultaneous equation. All those. Those are the things I want to work on. Don't forget, you are home with Further Solutions Academy. Further Solutions Academy. I encourage us more to share and subscribe if you have not subscribed before. These videos there are so lovely. Once again, thanks for watching.